This is our third video of the chapter Introduction to Trigonometry. In the second video, we have derived the trigonometric ratios for 0 degree and 90 degree. In this video, we will derive the trigonometric ratios for 30 degree, 45 degree and 60 degree. To derive the trigonometric ratios for 30 degree and 60 degree, we consider an equilateral triangle. Equilateral triangle ABC. We know that in the equilateral triangle, all angles are equal to 60 degree. So angle A is 60 degree, angle B is 60 degree, and angle C is also 60 degree. One more property of the equilateral triangle is that all sides are equal in length. All three sides are equal in length. Now we bisect the angle A. We bisect the angle A to meet the opposite side BC at D. So we have bisected the angle 60 degree. So we have obtained this angle as 30 degree and this angle is also 30 degree. So in this way we have obtained two triangles ABD and ADC. These triangles are 90 degree. 90 degree because here if we consider the triangle ABD, then this angle 30 degree and this angle 60 plus 30 is 90. So these angles are complementary angles. Angles whose addition is equal to 90 degree are called complementary angles. So these two are 90 and left we are having only 90 degree. That's why this angle, this third angle should be 90 degree, because the sum of these three angles should be 180. So this angle should be 90 degree and this angle should be also 90 degree. So we have obtained two right angle, the triangle ABD and ADC. These two right angle triangle are ABD. They are congruent. Triangle ADC. These two right angles are congruent. Congruent means they are equal in length and angle. They are equal in size and shape. These two triangles are equal in size and shape. They are congruent to each other. We have used the congruency. This is side angle side congruency. Side because in the triangle ABD, this side AB is equal to AC and angle 30 degree and this side is common side. So we can use the congruency side angle side. We have studied this congruency in our class 9. In class 9 we have already studied this congruency. So by applying as congruency, we can say that these two triangles are congruent to each other. Now in the triangle, in the right triangle ABD, we know that sine 30 is, some people have, but perpendicular for the acute angle 30 degree is perpendicular is BD and hypotenuse is AB. Hypotenuse is AB. So sine 30 is BD by AB. Now if we consider BD, the length of BD is A. If we consider let BD is equal to A, then we can see that length of BC is equal to BD plus DC, and we know that by congruency we can say that BD is equal to DC, because these two triangles are congruent to each other, so this side should be same. BD should be equal to DC. So if BD equal to DC, then we can write in place of DC, BD. This is equal to twice of BD, and BD we have considered it as A, so it's equal to twice A. It implies BC is equal to twice A, and it implies AB is equal to AC is equal to also twice A, because this is an equilateral triangle. So here the hypotenuse is twice A, this length is also twice A, and this length is A. So in sine 30 we can see that BD, we have considered BD as A, and AB is twice A. So sine 30 is equal to 1 by 2. So here we can write sine 30 is equal to 1 by 2. Now cos 30. Cos 30 is now cos curly brown here. Brown matlab base is AD. Curly brown hair, hypotenuse is AB. So base is AD. Now we have to find the length of AD. So in the right triangle ABD, we can use Pythagoras theorem using Pythagoras theorem. We get AB square is equal to AD square plus BD square. We want to find the length of AD. So AD square is equal to AB square minus BD square. Here AB, we know that the length of AB is 2A, twice A whole square minus BD. BD we have considered as A. So this is equal to A square, equal to 4A square minus A square, which is equal to 3A square. It implies AD is equal to under root 3A. So cos 30 will be AD, in place of AD we write root 3A. Then AB, we know that AB is twice of A. So A get cancelled out, is equal to root 3 by 2. So cos 30 we can write cos 30 root 3 by 2. So tan 30. Now tan 30, we know that tan is sine A divided by cos A. So 1 by 2 divided by root 3 by 2 is tan 30. Tan 30 will be 1 by root 3. Now we can write cosec 30. Cosec 30 is the reciprocal of sine 30. So it will be reciprocal of 1 by 2 is 2. And sec 30 is the reciprocal of root 3 by 2. So it will be 2 by root 3. Cot 30 is the reciprocal of tan 30. So it will be reciprocal of 1 by root 3 is equal to root 3. So we have derived the trigonometric ratios for 30 degree. Now we will derive for 60 degree. Now for 60 degree we can use the same equilateral triangle. So let's draw the equilateral triangle once again. We have obtained two right angle triangle ABD and DC. We have assumed AD be A, and so we have obtained AB as twice A, and this is also twice A. This is 30 degree and this is 60 degree. Now in the right angle triangle ABD, sine 60 is, some people have now P for perpendicular. Perpendicular is AD, hypotenuse is AB. AD, we know the length of AD we have found as root 3A. So root 3A, and AB we have found as twice of A. so twice of a. So it get cancelled out, so this is equal to root 3 by 2. Now sine 60 is root 3 by 2. Sine 60 is root 3 by 2. We have obtained sine 60, which is root 3 by 2. Now let's try to obtain cos 30. Cos 60. Cos 60 is curly brown here. Brown means a BD. This is the base by AB. So BD is A and AB is twice of A. So this is equal to 1 by 2. So cos 60 is 1 by 2. Cos 60 we have found 1 by 2. Therefore tan 60 will be sin 60 divided by cos 60. So it will be root 3. Now cosec 60 will be reciprocal of sin 60, so it will be the reciprocal of root 3 by 2, so it will be 2 by root 3. And similarly sec 60 will be reciprocal of 1 by 2 is 2, and cot 60 will be reciprocal of tan, so tan is root 3, so it will be 1 by root 3. So we have derived the values, the trigonometric ratios for 60 degree. So we had derived for 30 degree and 60 degree. Now we will derive the ratios for 45 degree. To derive the trigonometric ratios for 45 degree, we consider an isosceles right angle triangle. So isosceles right angle triangle is something like this, where the length of side AB is equal to AC. So length of the side AB equal to AC, and the angle A is equal to 40 degree and C is also equal to 40 degree. So this is isosceles right angle triangle. So in this right triangle, if we consider the length AB as A, so AC will be also A. So in the right angle triangle, using Pythagoras theorem, we get AC square is equal to BC square plus AB square, which is equal to BC is A square and AB is also A square, which is equal to twice of A square. It implies AC is equal to root 2A. So length of hypotenuse is root 2A. So we will get sine 45, which is again some people have. People means perpendicular. Perpendicular is this is the perpendicular P, this is hypotenuse, and this is base. So some people have perpendicular is BC, which the length is A, and hypotenuse is root 2A. So A get cancelled out, it is equal to 1 by root 2. Now cos 45 is equal to curly brown here. Brown means base, so it will be curly brown here. Base is AB, hypotenuse is AC, so AB is equal to A and hypotenuse is equal to root 2A, so this is also equal to 1 by root 2. So sine 45 and cos 45 we have obtained the value as 1 by root 2. So sine 45 is also 1 by root 2 and cos 45 is also 1 by root 2. So tan 45 is sine 45 divided by cos 45, so it value will be 1, and cosec 45 is the reciprocal of sine 45, so it will be root 2, and sec will be also root 2, and cot will be also the reciprocal of tan, so the value will be 1. So this we have obtained, we have derived the ratios for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. In this case, we can see that the values for sine is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. That means the values are increasing towards 1. It's increasing from 0 to 1. 1 by 2 is greater than 0, 1 by root 2 is greater than 1 by 2, root 3 by 2 is again greater than 1 by root 2, and 1 is again greater than root 3 by 2. So sine values are increasing from 0 to 1, and value of cos are decreasing from 1 to 0. The value of cos are decreasing from 1 to 0, and the values for sine 60 and cos 30 are same, root 3 by 2, root 3 by 2. And sine 30 and cos 60 are same, 1 by 2, 1 by 2. So we can memorize these values easily. Now we will apply these ratios to solve a simple problem. Let's take one simple problem. Let's evaluate sine 60 degree cos 30 degree plus sine 30 degree cos 60 degree. So solution will be sine 60, we have already obtained the value or the ratio for sine 60 as root 3 by 2, and cos 30 is also root 3 by 2, and the ratio for sine 30 is 1 by 2, and cos 60 is also 1 by 2, which is equal to 3 by 4 plus 1 by 4, which is equal to 1. So we can easily obtain or evaluate this kind of problem by just directly putting the ratios. So this was our third video. In the next video we will solve many kinds of problems using these trigonometric ratios. Thank you.